Alright, hello everybody. It is Andrew here, and I am back with another severe weather forecast for tomorrow, which is January 24th. Today is my birthday right now as I'm recording this. I'm recording this around 9 o'clock, and we're talking about a significant tornado threat tomorrow in two locations. One of them is southeast Texas into portions of southwestern Louisiana, and then another one is eastern Louisiana through Mississippi, southern Alabama, and into the Florida Panhandle. Strong tornadoes will be possible across both areas. A higher damaging wind risk exists to the east, and I do think significant damaging wind gusts is a very high possibility as well in this area, given the lower level jet, which we will talk about in a second. Large hail is excuse me if I sneeze, is more likely toward the Texas area. I would not be surprised if we see very large hail as well in that area, just given the fact that we have the warm front there and kind of the sheer elevated hailer profiles that exist kind of away from the warm front. Oh, sorry for the jump scare. Let's look into the environmental factors that are causing this. So we have a very potent upper level system that is currently located across portions of the Four Corners region just south of there in Texas or in New Mexico and Arizona. This trough is expected to speed up and eject over Texas tomorrow morning into the early afternoon. Right now we can see we have moisture advection starting to push in here across portions of Texas, but we don't have the ideal dew points, which is going to make the warm sector small for tomorrow. If we look at surface observations, we do have upper 50 and 60 dew points pushing into Texas as we speak, and I'll talk about the moisture return in a second. We have southeasterly winds now, so we're going to get more moisture return, and the moisture is rapidly increasing throughout Texas right now. Looking at that low-level jet, you can see why the low-level jet is 40 plus knots in most locations, which is translating as fuel, and it's a little bit stronger than expected at this point. As we go throughout 6 hours, we can see that low-level jets are really going to start to kick in, and we're going to start to see a lot more moisture kind of kick in here, and we can see dew points are expected to get up into the mid-60s across portions of southern Texas. Um, First, we're going to take a look at the HREF, and we're going to look at the 500 millibar flow, and we can see that trough eject into Texas tomorrow. Powerful 500 millibar flow is expected with this. Now, as we get down to the 850 millibar level, we're expecting this low-level jet to keep ramping up. The low-level jet's a little bit stronger than guidance suggested, so it's kind of have to combat that. We're expecting 40 plus knots of flow in the morning, and then we're really starting to kick it off with 60 knots of flow in the late morning, and then 70 knots as we get toward the afternoon. And then we're expecting extreme kinematics to kick in across portions of southwest Louisiana and throughout the rest of the night in Mississippi, Alabama, and Florida. I think southwest Louisiana is the point where we're going to start to see this go a little bit more linear, and we're going to start to see the potential for significant damaging wind gusts become a real possibility. Here's a look at the mean dew points. So right now it would be 3 Zulu time, and models are pretty accurate with where the dew points are, and we're expecting the warm sector to push over the Houston metro by tomorrow, and we're expecting another surge of moisture to occur. I do not think the severe threat's going to be as high in southwest Louisiana because there's a little bit cooler surface ocean temps in this area, which is going to kind of neglect the flow. Now the surface temps are way higher out in this area of the Gulf, so you're going to get better moisture advection as you get into Louisiana, Mississippi, and Alabama there, and Florida. So I think we might have the risk die down for a bit in central Louisiana. Looking into the HREF as it is underdoing temps a little bit. I'm gonna go on here and oh, that's Texas Tech model. We're gonna go to this cam verification site, and we can see it's underdoing temperatures for portions of Texas here, which is big time because this is the area kind of regarding the flow. And you can see the 0Z HREF is already underdoing temperatures by 1 to 4 degrees. It's overdoing temperatures for places further to the east, though, which is interesting. Um, I believe this is the temperature and dew point error for the 0Z HREF, and it's a little bit lower than expected across portions of Texas and Louisiana, so it's underdoing them a slight bit. HRRR is underdoing the temps a little bit too. The ARW is the model that's really underdoing the temps, and SSL is probably doing the best job out of any cam with that. Dew points. HRRR is handling them pretty good. It's underdoing them slight bit. ARW is underdoing them by 2 degrees or so in some spots, and the other cams are doing fine. I think the NSSL probably has the best handle on the event. Now let's go into the southern plains sector and kind of dissect the mesoscale environment that is being depicted here on the HRF model. This is a composite of all the cams. So we can see instability really starts to affect, and I think we get a line of supercells to initiate near San Antonio right around this time. And I don't know if you can you put other stuff on? I think you can put highways on, unless I'm tripping. No, you can't. Okay. But we're gonna see a line of storms start to form, kind of on this bullseye of instability that keeps advecting northward, and we're expecting this to really grow, getting up toward 2,000 joules per kilogram across portions of Texas as we get into the early afternoon hours. We're expecting that to keep advecting onshore. Now, I usually wouldn't use significant tornado parameter, but this is a situation where I would. It's not too bad on the HREF, and it gives you an idea of where the parameters maximize. So it looks like parameters maximize just to the west of Houston, maybe even into Houston as well. Um, so we're expecting the potential for a pretty significant environment, and I think this environment is equivalent to a 15 hatched, but I don't think the SBC is going to pull it because the overall area where a 15 hatch would be supported is a little bit small. Um, Again, looking at here, we have very supportive SRH values of 200 to 300, right where you have the better instability values, which is key. Um, I think the highest tornado threat's going to exist along the warm front in any of these points, so probably Houston area or so. I'm going to see that SRH bullseye move east and grow stronger. Um, that is going to do it with the HREF. Now let's move over to the HRRR and kind of look at that. So we're going to look at the HRRR here, and we're going to be able to look at more ingredients with the HRRR, which is great. So we can see here, supercells thunderstorms are expected to initiate 16 to 17 Z near San Antonio. These are going to move eastward and really start to grow. We're starting to see a couple supercells get depicted out ahead of the line on the HRRR, and I do think this line is going to be more of an embedded supercell look than what the HRRR is portraying. And I think we're going to go to 1 kilometer of reflectivity because that's going to really show you a little bit better of how the line's being depicted. And yeah, it's a little bit more embedded supercell structure, and I believe this is more of a realistic approach using the 1 kilometer reflectivity. If we take a sounding kind of near those discrete supercells, the environment is very potent tomorrow across Texas, and we're going to kind of talk about this. You have moderate amounts of instability, which is pretty good for this time of the year. 1,000 plus mixed layer CAPE is solid. Your lapse rates are not the best, but your CAPE is distributed pretty well throughout your profile. 6 to 6.5 will work for lapse rates. Your hodograph is the thing that makes this profile very impressive. Your storm relative helicity is off the charts. Everything is super streamwise with this hodograph too. You can just put it from a central point and everything is perfect, almost perfect hodograph pretty much for significant tornadoes. And Cameron Nixon put something up on his Twitter here that just perfectly encapsulizes kind of the significant tornado cases, and I will actually get that up as well because that is just what he put up on his Twitter page is very reliable information here. Here it is. So tomorrow's environment near the coast has plenty of SIGTOR analogs. So here's a couple that I use. He used Columbus, Mississippi, and that's very apparent here. I like the analog because of the hodograph. Really, this analog here, the Remnant Hurricane Gulf Coast outbreak, or Remnant Hurricane outbreak in 2016, the Remnant Hurricane type deal, that hodograph pretty much resembles it. And his analogs, the New Orleans tornado, I believe that's March 22nd, 2022. Molca Hill, you can just read those off for yourself. There's plenty of analogs he has out there. Um, this looks like a major, big time event for Texas. It's going to be more localized, but it looks pretty major. We can see the HRRR is depicting warm air advection supercells kind of forming in the warm sector there, but I'm not sure how strong these are going to get. I think these supercells are going to need to outlast the shear, which the shear is extremely strong, and I'm not sure if they're going to be able to consolidate enough. They're also going to need to deal with mergers, but the thing is, mergers would really help these storms out because they would give them more thick updrafts and they would be able to consolidate further to be able to take advantage of the environment as well a bit better. So any of these warm air advection supercells that do end up forming, we're going to have to watch them. The line of storms, or kind of embedded supercells rather, is going to have a very potent environment to work with as well. That's along the warm front just west of Houston on the HRRR. These photographs are potent. I mean, this is some of the best photographs I've seen, and these instability profiles are pretty good. The only thing I don't like is the saturation up to 2 kilometer, which could be a limiting factor, but you still have strong 0 to 3 kilometer instability. You can also see lapse rates are still decent. The problem for those prefrontals as well is the decape is a little bit high, 900 joules per kilogram. Um, we'll see how that works out, but yeah, the environment 21Z downtown Houston is very significant as well. If we take kind of a box sounding there, if the warm front does advect that far north, and actually I took the box sounding a little too big. If that warm front advects that far north into Houston, we're gonna have a problem. Hodographs are huge. You also have very strong amounts of instability as well, given the hodograph shape. So pretty significant stuff there. Now, I do think this is going to die down as you get into southwest Louisiana. Like I said earlier, those sea surface temperatures are not so good. Take a look at these photographs here. They're very solid, but the thing is, you don't have as much instability. You can see the stable layers are really starting to get keyed in here. You're starting to get a bit of an inversion as well, especially at the surface, so you're not going to be able to take advantage of this shear unless you have a sustained, well-matured supercell or kind of line segment that keeps going, which is possible. Now, I think the tornado threat's going to start to ramp up as you get toward 4Z out in the New Orleans area. I think there's going to be more surface instability that gets affected, and bam, there you go. These photographs are very classic for QLC or for QLCS slash embedded supercell type deals here. You have strong 3K along with very strong and streamlined low level photographs, and the venting's actually pretty good too for a situation like that as well. As you get further to the east, we're still expecting the potential for strong tornadoes as you get into Alabama, Mississippi, along with the potential for significant wind gusts as well. And that environment will stay supportive. Now, here's another thing that I want to track. We're going to track the 0 to 3 kilometer helicity tracks. This is going to show us kind of the amount of stronger updrafts. So we can see there's a lot of stronger updrafts that form within the QLCS or whatever across Texas, Louisiana, Mississippi, and Florida. Those areas just get slammed. Another thing I want to look at is the 850 millibar flow because that's a big aspect of this event as well. And you can see the HRRR really starts to pump that out, bringing up moisture advection because of how strong that low level flow gets. And you can see it gets up to 70 plus knots, which will not take too much to translate that down to make a significant wind threat of reality. Now let's look at the NSSL. This is another one of the models I like to use. You can see here it develops some embedded supercell structures out there, west central Texas, and again, the environment is very potent. It's not just the HRRR depicting this more to potent environment. Now, it does have a little bit more of a warm nose, which could be a bit of a factor. These photographs are just significant. These are pretty classic Southern Plains photographs. Very well vented too, especially for an early season event. Your upper level flow is super good. And you can kind of see these kind of move off further to the east, and they really get going down in southeast Texas, and then we see this line keeps chugging along. Next layer, let's go look at the dew points and kind of look at our warm sector because that is a big thing here. We're kind of comparing everything. You can see here, major moisture keeps getting advected northward in Houston as well in your warm sector there. So yeah, again, another model that has Houston in the warm sector, and you can see that kind of secondary wave of moisture that gets up into Louisiana, Mississippi, and Alabama there, enhancing their threat into Florida. Now let's go to 20, probably what, 21Z is where the peak environment for Houston is, and let's kind of compare the models here. So I like to do this by going to compare models, and we'll go compare the RAP, the NAM 3 kilometer, the NAM 12K, the NSSL, the FV3, ARW, HRRR. We're going to all compare these because these are the more reliable models. So you can see here, they're all agreeing on Houston being in a very significant risk, or very well into the warm sector, and at potential for a significant risk of supercells capable of producing stronger to intense tornadoes, maybe a longer tracked one, but the warm sector might not support that as much given the fact that it's a little bit small. But we could see supercells ride the warm front and keep that and keep going because of that well-sustained storm relative flow there and storm relative listing. You can see the instability does exist further up to the north, but it's pretty skinny still. ARW again has another scenario pretty similar to the NSSL, except it doesn't go as big with the event. I don't think. I feel like it has a lot more crap vection kind of going over Houston, and the warm front gets convectively reinforced, so Houston dodges a bullet, but still other areas would get significantly hit if that happened. Environment's potent along the coast there by Galveston, Port Lavaca, areas like that, Victoria. So currently my thoughts on tomorrow. We'll kind of go over to an overview here. So I'm currently thinking we're probably going to see a pretty big tornado risk evolve out here from kind of this general region out in here. It's going to stop for a little bit. You'll probably still get tornadoes, and then it will probably ramp up again in here with significant wind gusts and stronger tornadoes being possible. More brief tornadoes probably. I think the more longer track tornado potential would exist in Texas and the extreme southwest Louisiana. Thanks for watching this, guys, and I will see you in the next one.